classify this as the black water and gray water. The black water is generated from toilets and it contains high concentration of pathogen. And gray water is generated from all sources of utility except toilet. It's also again, because it varies from country to country or in areas also. Certain people like Bangladesh, they treat only black water, they discharge gray water because they got a perennial river. But in Tamil Nadu or in India, we club together and treat it. So general parameters of this already know that it's a pH in the range 6.5 to 7.6. Chemical oxygen demand and an average we get 600, but Chennai city we have got only 400 milligram per liter. Biochemical oxygen demand varies from 300 to 600. Chennai it is only 200. Total suspended solids in the range 200 to 300. Normally we get about 200 in Chennai. Total dissolved solids 500 to 700. That's what he said. The total dissolved solids, since it's very less in the municipal wastewater, completely made use of or make use of this for resource purposes. Sulfides in the range of 2 to 3 milligram per liter. These are the wastewater pollutants present in that. And of course, why this the Adair River and Kosasthala River and they have been contaminated due to the presence of heavy metals discharged from the sewage. Because not only this, biochemical oxygen demand, chemical oxygen demand can be treatable or otherwise purified by its course of this water stream itself. But because of the presence of high TDS, they are not able to make it up. And the DO content of the sewage is said to be very, very low. Previously, they used to have that many types of fishes in this rivers, but now we don't have any visibility of seeing the fishes in the rivers. Mainly due to this, DO level is very much low, and also dissolved concentration of the sulfides is said to be very high in the rivers which have been collecting this sewage. And of course, we found that methane emissions is equivalent about 643 milligram carbon dioxide equivalent is available from the untreated municipal sewage because openly it's going around this in the rivers collecting this sewage. And this nitrous oxide emission also very much higher. It is equivalent to carbon dioxide about 187 milligram. And irrigation by sewage water, some part of this the untreated sewage also being used for this irrigation for raising this green that is greens, and some of the vegetables are also grown on this using this untreated sewage. And also this pharmaceutical health chemical products. That's what I wanted to stress, that because my more research or more technology concentrating on this, how this pharmaceutical health chemical products, it is nothing but emerging contaminants present in the sewage. It is causing lots of issues to this, the reuse of wastewater. So this what's that? That is a collection tank, goes to this screen, and after collecting this floating solids, and then it passes to the equalization tank, and of course the settling tank for take over the grids. And anaerobic, certain part of this or certain flow sheets have got this anaerobic treatment, followed by this activated sludge process. That is, all the configurations available so far now are said to be having this, the activated sludge process. And after this, the separation of suspended solids or biomass from it and goes for the recovery of water, or otherwise after disinfection, this water is fit for discharge into this, the sources they pointed out. But since that zero discharge disposal has been enforced by Pollution Control Board, now they have to use ultra filter to recover water for utility purposes, already given on the flow sheet. And now this municipal wastewater discharge from the CSTP or otherwise STPs, they have to involve ultra filter and for reuse purposes, already given on the flow sheets. This what, sir, we say that the conventional treatment about this screens, grid chambers, skimming tank, grease street, and this is source of having some sludge generation. The primary treatment, with the conventional treatment, they are producing sludge. And secondary biological treatment, as you know, that anaerobic biological treatment, of course, in addition to generate methane gas and of course generate the sludge also. So that secondary biological treatment also has a source of the generation of sludge. So conventional treatment generates sludge both in the primary treatment and secondary biological treatment. Next. So that's what the refractory organics present the treated wastewater, number of toxic elements, including heavy metals, are said to be present. Surfactants, naphthalamines, benzylamines, detergents, antibiotics, hormones, steroids, and in addition to that, pathogenic, non-pathogenic organisms and viruses are said to be present in the treated wastewater discharged from this conventional wastewater treatment plants. Next slide. And what are the issues with the untreated municipal wastewater for greenery development? I just say that. Next slide. Issues with the conventional technology, generation of sludge. That's what I say that. This is a very important point to be noted, that the conventional technology generates huge amount of sludge. And of course, wrong notion is the sludge can be used as a manure for garden or greenery. That is a wrong concept. Many of the people are following that. That is a wrong concept. They are doing it. And the generation of foam by the conventional technology, emission of odor or smell, and emission of bioaerosols. Some bacteria, virus, and so on said to be released from the conventional technology treatments. And the presence of residual emerging contaminants and soluble microbial pollutants. This is also important thing to be addressed, because when you are trying to use that water for reuse purposes, and one is we have to avoid this generation of sludge, and another one more emission of bioaerosols to be avoided, because these bioaerosols condense on these soil structures, they get washed out during the rainy season and goes back into the soil or groundwater sources. And presence of residual emerging contaminants present in the treated sewage and soluble microbial protection, so that any conventional technology addresses to this or not. This particular slide shows that very important thing. And we consider aerobic bacteria. So aerobic bacteria, we say that's a source of biomass. And when you consider this raw sewage water, that is COD, if you consider that, chemical oxygen demand is made up of the soluble soluble organics biodegradable. And similarly, soluble organics non-biodegradable. These two are present as contributing to COD. In addition to that, particular materials, that suspended solids, biodegradable suspended solids are available. That is, non-biodegradable suspended solids are available, and insoluble non-biodegradable suspended solids are available. So these are said to be particulate material. So when you consider this wastewater, when you pass through this waste treatment plant, and soluble non-biodegradable organics just escape and go to the treated water or treated conventional wastewater treatment plants. And this would be present in this. That's what this consists comprising of emerging contaminants and the healthcare products and so on said to be present in the non-biodegradable soluble organics.